Hello, welcome to my presentation on the eBook Store and Library Management System. My name is Helen Castro. I have developed this project to address the growing need for efficient and scalable eBook management systems. My agenda on this presentation is going to be our introduction, primary goals, database design, and demonstration of database functions. So I chose this project because of the increasing popularity of ebooks and demand for digital libraries. My goal was to create a robust system that can manage ebooks, their users, and transactions seamlessly. The significance of this project lies in its ability to streamline the processes of borrowing, purchasing, and managing ebooks, providing a user-friendly experience while ensuring the system's scalability and efficiency. I myself have a Kindle. I love my Kindle. It's amazing. It does stop me from borrowing too many books, so that's basically what I worked around for this project. So primary goals was efficient management. This system will simplify the management of ebook and users and transactions, reducing administrative overhead. The user convenience, it offers a seamless experience for users to purchase or borrow ebooks, enhancing user satisfaction. As for the scalability, it's designed to handle a growing number of users and transactions, ensuring a long-term viability. Our data integrity ensures data accuracy and consistency through well-defined relationships and constraints. And business insights for this project provides a valuable insights through detailed reports, queries, aiding decision-making processes. So this is a diagram of my entity relationship. We have a user column which has the user ID, name, email, password, role, membership status, and the primary key for that is going to be the user ID. The relationship is that each user can have one or more cards and can place multiple orders and can borrow multiple ebooks. And then we have the ebook table. It has the ebook ID, the title, author, genre, price, stock quantity, availability status. The primary key is ebook_ID. Each ebook can be part of multiple orders and borrowing, so that's one of the relationships that I made sure it had. Then we have our cart. The cart has attributes, which is the cart ID, the user ID, and the created at. The primary key for this is cart ID, and the foreign key would be the user ID for references for the user. Relationships for this would be each cart can contain multiple cart items. We have our cart item table, and the attributes are the cart item ID, ebook ID, and quantity. The primary key for this would be cart_item_ID. The foreign keys are cart ID, which references the cart, and ebook ID, which references the ebook. And each cart item belongs to a specific cart and ebook. That would be the relationship for them. And then there's the order table, which attributes are order ID, user ID, order date, total amount, payment status, shipping address, all of the information you will need when you want to buy a book and get it shipped to your home. The primary key is the order ID. The foreign key is user ID, which references to the user. And the relationship for this was each order can contain multiple order items. So each order cart can have as many books as they want on their cart. Order item, which attributes are the order item ID, ebook ID, quantity, and price. Primary key for it would be order item ID. Foreign keys are order ID, which references to the order, and ebook ID, which references to the ebook. We got the borrowing. Attributes are the borrow ID, user ID, ebook ID, borrow date, return date, and the status, as in if it's borrowed by someone or if it's pending or you're not allowed to borrow it because someone else has it. So the primary key is borrow ID. Foreign keys are user ID, reference users, and then ebook ID, which references the ebook, of course. And each borrowing record is associated with a specific user and ebook. So the key constraints here are the primary keys, which ensure each record is uniquely identifiable, and the foreign keys maintain referential integrity between related tables. The unique constraints ensure the uniqueness of certain fields such as email in the user table. And that basically is the sum up of my diagram. So here we have our database functions and queries. This query retrieves all the records from the user table. It returns the user ID, the name, email, password, role, and membership. Status for each user in the system. This query is useful for viewing all users and their details clearly. The ebook table stores information about the ebooks available in the system, including their title, including the author, the genre, price, stock quantity, and availability status. Okay. Here's a query that I use to select from ebook where in the availability status to make it true. This query right here, this means it lists all the books that are currently available for purchasing or borrowing, filtering out those that are not available. The rest includes all columns from the ebook table for each available book. So as you can see, the only available books here are a few of Court of Thorn of Roses, Iron Flame, Confess, Ugly Love. But as you saw prior, we had other books. Those are the books that are available to borrow. These are books that are available to purchase. Okay, and then we have this query with select from ebook where author equals J.K. Rowling. This query filters the results to include only the ebooks written by J.K. Rowling. The result includes all the columns from the ebook table for each book by J.K. Rowling, such as the ebook ID, title, genre, price, stock quantity, and availability status. Okay. Now we have another query here where it's select from order where user ID equals 1. This query filters the results to include only the orders placed by the user with the ID of 1. The result includes all columns from the order table for each order made by this user, such as the order ID, the order date, the total amount, the payment status, and the shipping address, which is right here. All of the information you would find right here, which is only one row because the user ID only is collective to one user who has that one exact email, which is the uniqueness. Okay, here I have another query. It's select title, author, stock quantity from ebook, where stock quantity equals the max from ebook. This retrieves the title and stock quantity of the ebook that have the highest stock quantity in the ebook table. The result of this query will include the title, author, and stock quantity in the ebook table. If multiple books have the highest stock quantity, all of them will be included in the result. Since Harry Potter and the Sorcerer's Stone is the highest one, it's only one in the row set, which would be the quantity would be 200. And then we have another more in-depth query. It's select title, author, sum of OI quantity as total purchase from order items. Then we joined ebooks, and then we grouped ebook ID, title, author, and order by total purchase. Okay. This retrieves the title and the author of the most purchased ebook along with the total number of purchases. The result of this query will be a single row containing the title, author, and total number of purchase for the purchased ebook in the database. This query helps identify the most popular ebook based on the purchase quantity. And as you can see here, it's A Court of Thorns and Roses, Sarah J. Maas, total purchase, 7 in total. Here's another one where we select ebook ID, title, author, price, stock quantity, availability status from the ebook table where the genre is romance. Okay, this result of this query will include all ebooks that belong to the romance genre. The columns will be the ebook ID, the title, the author, the price, stock quantity, and availability status. Okay. Alright, so in this presentation, I highlighted my ebook store and library management system designed for efficient and scalable management of ebook users and transactions. I demonstrated its robust data structure through an ER diagram and showcased key functionalities via SQL queries, illustrating effective data retrieval and manipulation. Hopefully my system ensures user-friendly interactions, data integrity, and valuable insights. Thank you so much for your attention, and I look forward to further improving our system based on your feedback. Thank you so much.